Hello and welcome to BYK. I would like to give you today a short overview about my latest new product development, BYK-1880, Airless by Airless defoamer. My name is Mathis Kulessa. I'm working since nearly 20 years at BYK, and I have a little bit experience about airless or air-assisted airless applications. So before we come to BYK-1880, our new defoamer, I would like to go a little bit into basics and want to speak about the challenges in airless applications. So if we compare airless and conventional spray applications, for sure, airless applications, in most cases, you have a higher viscosity and for sure higher solid contents in that case. You have a much higher pressure compared to HVLP applications. So there we work with 1.2 to 2 bars, and airless quite often something around 100 to 250 bar. If we talk about air-assisted airless applications, we have, let's say, 120, 130 bar, but airless, sometimes even in heavy-duty applications, 250 or even higher. And one nice benefit with airless applications is for sure I can apply with one spray pass a lot of material. But that tends for sure also to a much higher risk, especially of microfoam. So in airless applications, many people are using high solid systems because high solid is a very big trend, what we see at this time in general industrial coatings. Why do they want to change to high solid systems? For sure, they want to reduce VOC. And if you would like to reduce VOC, you have only the chance to change the coatings technology. So for sure, you can go with powder, you can go with UV or electron beam, you can go with water-based systems, but in my opinion, the best chance is, or the best choice is, to work with high solid systems. If we talk about high solids, there we have also some challenges. The biggest one is viscosity reduction. Because you want to have high solid, you need to use less solvents, and viscosity reduction is very important. Pigment dispersion is also one challenge, and the biggest one is for sure foam. And especially when we apply them airless, we have always a problem with foam. So let's compare again conventional versus the airless spray application. In conventional spray applications, you have low pressure, round about, let's say, 2 bars in HVLP applications. You have a low viscosity, in most cases, something around 24 to 28 seconds in DIN 4 cup. And you have a quite big nozzle, so usually 1.4 to 1.8 millimeters, and yeah, a very low viscosity that is very helpful in that case for leveling and so on. If we compare now to airless spray applications, you have a very high pressure, as I said before, 100 to 250 bar. You have high viscosity, and you have a very small nozzle. So from on 0.28 millimeters up to 0.45 millimeters. So all this big pressure needs to go through this little nozzle, and yeah, you create a lot of difficulties in that case. So for sure, here you see it again, just as an application example. The conventional spray, usually foam stabilization is not that big issue. because you can use a lot of solvents or solvent combinations to get rid of the foam in that case. If you have foam, it is mainly microfoam and only low amounts of microfoam. So HVLP or conventional sprayed systems are much easier to defoam. If we come now to airless applications, you have a strong foam stabilization. It is in, let's say 90% of all cases, microfoam, and macrofoam you will not see that often. And defoaming in that case, everyone who ever has done some airless spray applications will know that it will always cause a lot of foam. And yeah, I would say we found a new solution in that case, the BYK-1880 airless by airless defoamer. And in that case, we have a new and unique patented ABC structure. We have a polar modification, the polysiloxane, and another polar modification. And that is really something unique, something what we not have or never had before in our product portfolio. And frankly spoken, I have tested, let's say, 180 different lab products until we came to that defoamer. And that defoamer is really a secret weapon against foam in airless applications. So the BYK-1880 is a liquid, slightly turbid product. And I always recommend to add the BYK-1880 in the letdown stage, because the 1880 should work at the end, or let's say in the final application. And therefore, if you put all the amount in the mill base, you will lose the effectiveness of the defoamer due to the grinding and milling process, and therefore use it in the letdown stage, and it will work. If it's maybe too incompatible, you can make a little trick and add 2/3 of the defoamer in the mill base and 1/3 in the letdown stage. As I said, we have here a silicone defoamer for solvent-borne and solvent-free systems. It is 100% active, and I would always recommend to start in your trials with 1% of delivered BYK-1880, because then you will see if the product is working. If you end up with some defects, you can reduce every time the amount. But first of all, try 1%, use it in the formulation. If there are some difficulties, reduce the amount, everything will be fine. So what are the benefits of the BYK-1880? We have a highly efficient defoamer, let's say a secret weapon against microfoam in airless or assisted airless applications. It is strong. It is a very strong defoamer, but still very compatible. It is for a wide range of film thicknesses. It will provide excellent defoaming properties. It is suitable for all glass levels. You can use it in matte systems. You can use it in high gloss systems. Usually the 1880 has no influence in that case. You have no negative impact on adhesion, leveling, and as I said before, gloss. And it is highly recommended for 2-pack PU systems. And because it's a modern product, I would use it for sure for high solid systems, but it is also usable in low solid, medium solid, or all other systems. For sure, we have low cyclic siloxane content below 0.1%. So, and now I would like to show you one of our highlights. We made a little video for the introduction of this defoamer. And here you see a spray application. So it's an airless application of a high solid system. And you see here in the application that the air is really dragged along with the coating and sprayed on the panel with a very, very high speed, and the air is really entrapped into the coating at the surface. We usually do a vertical drying because that's the most critical part. And here you see that the BYK-1880 is a really strong, active defoamer, working very, very fast. It pushes the air to the top, and you see the sparkling effect. It is really a strong one. And that was quite fast. I would like to show the video once again. So as I said, high solid white top coat. The air is really dragged very quick with the coating onto the panel. That is really a very, very big challenge and not easy to get rid of the foam in those applications. And here you see really this quick acting, the bubbles are coming to the surface, they're popping very, very fast. And that is something where I really would say that is one of the best defoamers we have in our portfolio. So here we have another little example, especially black top coats are very challenging. Here with the BYK-1880, we were able to find a very good result. And here you see a black high gloss top coat. You see that there are no defects. For sure, it is a real airless application. You see that the surface is not perfect, but this is a typical appearance of an airless applied top coat. And one thing what I want to mention is our pour out pre-test, what we usually do here in the lab compared to the airless application. So when we started with that project to find a new defoamer, we have done tons of trials with this defoaming pre-test, and we figured out that it is not 100% fully comparable to the later on application. And you see that here with the BYK-1880, that the pour out is a little bit worse compared to the real application. So that is something for sure. The pour out test can give you an indication if the defoamer is working, but it will not prevent you in front of the real application. So this is something I just want to mention. If it will not provide you perfect results in a pre-test, please use it also in the final application. And you see that also here in those pictures, the pour out test compared to the airless application. You see that with the 1880, there are some little bubbles left in the pour out, and in the final application, it is really perfect. Yeah, so if you do airless applications, we have here a little recommendation chart. That is something what I like, what I really prefer this chart, because we have a portfolio of, let's say, 200 different defoamers, and how to choose the right one. And for airless or air-assisted airless applications, the starting point, in my opinion, is always a BYK-054, 1790, and for sure a BYK-1880. If those ones are not working, you can go a little bit underneath it. So alternative options are for sure a BYK-085, a BYK-A530, or the other mentioned products. And a little trick which is also very helpful are the combination partners, the BYK-392 or 354. So in many cases, you have, let's say, 95% of foam you get rid of, but you have a little bit left on the surface, on top of the coating. In that case, a BYK 392 or a BYK 354 is really a good combination partner. So usual ratio, you use 0.8 to 1% of good and strong defoamer like the BYK-1880, and let's say 0.3 to 0.5% of combination partner BYK 354 or 392. Yeah, let's summarize. The BYK-1880 is your solution to get rid of microfoam in airless or air-assisted airless applications. So if you want to learn more about that, or if you have some questions, you're always welcome to contact me or my colleagues. Thank you for your kind attention.